Okay, so Elon Musk has tweeted saying Starship departs for Mars at the end of next year, carrying Optimus. If those landings go well, then human landings may start as soon as 2029, although 2031 is more likely. Now, this is a bombshell of an announcement. We've discussed this scenario so many times here on Over the Horizon. And of course, it's a warm, fuzzy feeling to hear Elon say it. With me is Dr. Scott Walter. He's a mechanical and aerospace engineer and two-time founder of robotics companies. He's also one of the best science and technology communicators I have ever known, and it's always such a joy to have you on, Scott. So thank you and welcome.
Okay, yeah, thank you for having me back.
Great. So we've said it so many times before, and now Elon says it. Validation, or was it obvious?
Well, I guess it's obvious that you probably would want to have a precursor mission that would be mostly autonomous with some kind of autonomy or robots there. As far as the timelines, I guess this is probably the optimistic timeline, if I can make a pun, because there's a lot of things that have to go right for this to work. Starship itself has to be able to do everything. It has to be able to kind of actually be able to land on Mars, survive there, and everything else. But assuming you can do that, let's really focus on the bots, because this is what it's about: is sending humanoid bots to Mars to sort of prepare the landing site for a human mission. And this has been outlined already.
Yeah, very quickly, just to touch upon something you just said. Does Starship need to be reusable in order to go on a one-way mission?
No, I mean, just the boosters need to be reusable. It just needs to be able to survive the reentry of the Martian atmosphere. So obviously the testing they're doing for reusability here on Earth is going to tell whether it's robust enough, what kind of heat shielding, everything they have. The question is whether this is a one-way trip or whether they then want to be able to come back. The assumption is that they probably want to come back, because it's not really going to be set up yet, except for people who are extremely adventurous. I actually kind of pushed this idea 25 years ago that the best way to go to Mars is like one way. Is like, let's forget about this return stuff. Let's if you put all your engineering energy into actually being able to survive on Mars, rather than trying to figure out how to do the round trip, it's a lot easier in many ways, because you don't have to worry about a vehicle that's able to return, do all these other things. It could be for people who are very adventurous, and let's just say maybe already up there in years. So it's not like they're throwing away the good years of their life, but who knows? They may be considering these actually the good years, because if you're a scientist and explorer, this is what you've always dreamed of, being able to do something like that. So there could be some way of doing it through resupply missions and stuff like that, but it would be really a small colony that probably want to call it Jamestown, because you remember how that turned out. So so then you'd be looking at coming back. So if you're looking at the return trip scenario, Dr. Robert Zubin has laid this out, I think well over 30 years ago, that your first mission is actually an unmanned mission to set up a base and to start the production of the volatiles that you need, oxygen, water, fuel, and everything else, and using some sort of robotic vehicles or robotics to set these things up. So there's all sorts of things. It's just, it's like setting up any kind of campsite. Is like, everything is already packed up to get there, and then you got to unfold and move everything around, which we saw the astronauts do on the moon. They had to take all these experiments out and put them out. And it's going to be the same thing of setting up some sort of habitat and, production facility. You need energy. The discussion that the RTG, because solar probably won't cut it as far as being able to produce the amount of energy you need to start producing what you need over a 2-year span. And so the thought was you'd use an RTG, which is a radiothermal generator. So radioisotope thermal generator.
Which the rovers already have on Mars.
Right? They have something like that. But what they would actually have to do is they need to be sited a little bit away from the camp. You don't want them right there. So, I mean, there's things like that would require kind of moving these things
because of dangers.
Yeah, because it's radioactive and stuff like that. So part of it, this is laid out in Zubin's book, that you'd want to have it, certain distance, maybe a kilometer or so away, just to make sure that you're not getting exposure to it, because you're already in a highly radioactive environment as it is from cosmic radiation, everything else, kind of shielding you need to have. So there's all sorts of things that you would ideally would like to set up, and so you need some worker bees to be able to do it. So it makes sense, and that you would do it. And we've already sent robots to Mars. They've been there since 1976. So it's just, we're talking about a different type of robot that would be able to
Yeah.
accomplish tasks that typically you would reserve for like an astronaut.
Yeah. It's interesting that, I mean, people often don't think about it, but I always think as Mars being the only planet that's colonized by bots.
Yeah, exactly. And we're going to lean into that just a little bit. But you know, the first thing is like, you know, whether Starship's actually going to be ready for the Martian environment.
Right.
There's this, you know, big concerns that the avionics on there have to be upgraded, because it turns out the avionics that you expect that work really well in, you know, in low Earth orbit and everything else are going to be experiencing some slightly different challenges in the Martian environment, especially if you want them to be robust. So there's probably going to be a lot of upgrades, and whether Starship is going to be ready for that within 2 years or something else. But let's put all that aside. Let's focus on the bot. Is the bot ready for that? And I think the first question I want to ask you, Royden, is that whenever the discussion of humanoid bots comes up, everyone keeps on talking about form factors. And, you know, why the humanoid form factor? Why, you know, what's the standard answer to that?
Well, the standard answer, as far as I've heard and know, is that the world is built for humans, or we've built the world for humans to interact in a very human way. So a humanoid bot would be the best form factor to continue and build on
Exactly. For Earth.
For Earth, yes.
Are there any humans living on Mars? Has Mars been terraformed in any way? Has anything
Not that
happened
we
to the
know
land?
of, despite those square structures that you see.
Right. So you know, right now I'm going to say let's hold off in a second and ask ourselves whether Optimus is the ideal form factor for whatever it is they want to do on Mars. My assumption is Optimus is not going there to be an explorer. Well, there'd be a little bit of exploration and a little bit of science. It's not going to be the explorer like we typically see with these rovers, which are traveling long distances. So it's going to be exploring around its base camp, trying to do everything. So is in its current form the ideal form factor that you would want to have. And the reason I bring this up is there's a couple of major differences when you get to Mars. And one, as we all know, is gravity, right? And if you bring Optimus in its current form, you're going to have what will be known as the John Carter effect. And if you remember, the movie John Carter is about, you know, an Earthling that goes to Mars and suddenly is like, has superhuman strength because the gravity is so weak. That was Edgar Rice Burroughs novel that was turned into evidently a really horrible movie that didn't do very well.
Disney, wasn't it?
Yeah, I'm not sure who did it, but they definitely they could have done a better job. Anyway, so when it comes right down to it, it's like Optimus might be too strong, maybe, or let's say over-engineered for that environment for a couple of reasons. And the other thing is that is going to take some getting used to. So we've seen what it's like for the astronauts walking on the moon. They got 1/6 gravity. And I was able to personally experience 1/6 gravity a year ago when I went on a 0G flight, and a couple of the parabolas we did were actually at 1/6. And I was surprised. It's like how like low that gravity is. You know, it's like you would try to walk and you quickly got a very, very big stride. And it was interesting. Now, actually, I found it more enjoyable than 0G. And there was another passenger on there. We both agreed afterwards, like, you know, we like to have done more of the moon stuff. It was actually more fun because you got a little bit of control of your body. Now, Mars is like 1/3, but still it means the energy that you need to walk is very different. You're going to be able to bound. So that means, let's go ahead and change everything. The other thing is I think, you know, these bots, you know, they might have like a 30 or 40 kilogram payload that they can kind of do. And of course, when we say 40 kilogram payload, we're talking really about what it feels like to us on Earth. It's really newtons we have to talk about. You got to multiply that by gravity. So if that's still the requirement, that you need to be able to lift a certain amount of weight in that environment, then your robot can be a little bit wimpier. That doesn't need to have the same strength. Or maybe say, well, that's fine because we really want it because we're going to have these items which are very heavy there. So I would think the optimal form factor is going to be a little bit different. Now, there's a video I'd like you to bring up of the Unitree bot, which some people may have seen, and that in about a month, there's going to be a half marathon in Beijing, and all the Chinese bots are going to be in it. They're going to try to compete in this. So it's going to be very, very interesting. And right now, a lot of people think, you know, it's like Unitree probably has the best chance of winning this thing, even, and the dark horse is probably Engine AI, and who knows, maybe someone else. But when you look at this Unitree bot going around, it's remarkable on how well it's going around. But there's one thing I want to point about this bot and a couple of other Chinese bots that you're seeing that are out there. And that is, do you know how tall they are? Oh, look at the guy. It's a little guy. Okay.
Yeah.
And
I think they're a little under 5 foot tall, right?
Right. I think they might be like 4'6", and Optimus, I think, is 5'8". So it could be that you don't need to send a 5'8" humanoid to Mars, because for the most part, remember, there are no buildings or parks or cars or anything that are designed for people, the nominal size of 5'6". And the only thing is that whether the things they need to interface with, which are probably sort of designed a little bit for humans, the equipment that's going there, do they need to be that tall? I would argue you'd want to send a smaller version. Part of it is because it's a lot easier to locomote. I mean, this is why these bots are doing so well. It's like, let's take a foot off their height, and we'll probably be able to do a lot more. The other thing that does is it cuts your mass down significantly. So the lighter these things are, the more we can send. And that means the more redundancy we have, a lot of everything else. So if you also scale them down,
Olympic gymnasts, most of them are really short.
Yeah, they're under 5. Yeah, exactly.
So what does that tell you about the human biomechanics and the effect?
It's everything. Body control. Yes. And now, I'm not sure. It might. Who knows? We'll have to find. I'm trying to check with some biomechanicists. All right, what's the function of the ideal height as a function of gravity? Do you want to be taller on Mars? Do you want to be shorter on Mars? What is it easy? Because again, the way you kind of respond to it, there may be some arguments that 4'6" might be a better size for that. Your mass goes down, everything else. The other thing to remember is that you want to scale your servos down, because a little bit. So you reduce, you have a certain amount of weight that you have to do. So you're constantly having to fight gravity. So when I'm doing the stride, I'm having to lift my legs. My legs are having to fight gravity going on up, but it's fighting a little bit less. Now, the thing is, even if gravity goes to 0, I need to have a certain amount of strength, because there's one thing that doesn't change in gravity, and that's mass. I mean, that's why we define everything as mass versus weight, is that the mass of something on Earth is identical there. And there's this other kind of, and mass is basically inertia, and that is resistance to changing its direction, that Newton famously talked in his laws. Yeah. So if a body at rest wants to stay at rest, and then whether you're on Mars or Earth, the amount of force you've got to push on that thing to get that thing to kind of move, so long as it's not having to go against gravity, is going to be the same. And you also have this concept of rotational inertia. So a lot of the mass you have along here also is like resistance to this thing going to rotate and stop. So there's this really nice flywheel that's like, well, the servos don't have to be as strong. If the servos don't have to be as strong, I can make everything lighter and stuff like that. It's like this really virtuous cycle that you can have much smaller bots that would be able to, say, perform a very similar kind of capability and make it easier to send to Mars. Because you could send a lot more of them. So it's like, well, if we, Optimus's current form, we can send 1,000, but maybe make them smaller, we can send 1,500, because the mass will go down, and then you have that redundancy.
How many Optimus or Optimi do you think Starship could take?
Oh, it could. I mean, I think they've talked about it being able to send like 100 people or more. It's like we keep on hearing all this. Potentially, it would be kind of cramped for 9 months and stuff like that. But let's not forget,
if you're sending people, you need a different sort of.
You need life support. You need everything. They need space. You need life support. You need, and the thing with these bots is that you can pack them up really densely, and you don't need air, you don't need water, you don't need food, you don't need sanitation. There's all these things you just absolutely don't. So again, let's start talking about it. It's like, remember, we're now going to be talking about a world which is designed around robots as opposed to people. So that first Starship is not going to have a human pilot. There's no human system on there. So like I said, you're getting rid of the kitchen. You're getting rid of the toilet. You're getting rid of the air and the filtration and all this stuff.
A lot of space saved.
Yes, absolutely, and a lot of mass as well. And then these robots, you just pack them on up, and so you could have a huge number of them, depending upon what makes sense for the mission. And,
And Starship
redundancies.
would also, by extension, be the charging base.
Yes, yes, yes. Now the question is whether it's going to be doing that purely through solar, or whether it's going to have other forms of energy generation, because these bots are going to be power hungry. The other thing I've always said
So
about Mars.
RTGS being an example of nuclear.
Yes, yes, yes. So
Do you think
that would,
there's a possibility for miniaturized nuclear reactors that could be sent,
you
or would
never
it be
know,
dangerous?
because thorium reactors are very compact. I mean, Bill Gates has been working on this
Yeah,
for years,
right.
of talking about these very compact. I mean, it could almost
I
be
think
that
GE is also
yeah.
been working on one of them, right?
And they're so small that literally you could go to a subdivision and drop one
Yeah,
of them in the ground, and it would
yeah,
produce all the energy that subdivision needs for like
right.
100 years. And then the thing is, people would forget that's even there under the ground. I mean, it's like, you're not talking about something that's really big. And
Yeah.
so that's possible
And how about
using these
sending
other.
megapacks?
No, too heavy. I mean, see, I think, and this is already a question
But
that
you
you
would
have.
need some way to store the energy generated, right,
Yes,
through a nuclear
yes, yes.
reactor, because you can't
And
just continuously use it.
right. See, that's all. This is why, like, hydrogen fuel cells don't work well as in an automobile, is that they cannot um, change their power output on demand like you do in a car. Like you hit the accelerator, those batteries give you the energy you need at that moment, and then when you back off, they go. And the thing is, like with a nuclear power station, stuff like that, they have a baseline. You just can't crank them up and crank them down. It's like they're out there, and if you've got excess, you'd love to be able to grab that excess somehow. And that's how a hydrogen fuel cell works: is that you've got a battery that is basically charging. It's a hybrid. I mean, it's like people don't realize, a hydrogen fuel cell car is basically a hybrid, that you've got something that's generating electricity that's being
Yeah,
stored, and that battery is a thing that is then driving all your electronics, because from that you can control the flow.
yeah.
So
So some
it's
sort of battery structure to store
yeah,
energy.
you would
You
need
think
that. Now
megapacks might not be the one.
it's yeah, because first of all, batteries are just heavy. I mean, you don't want to send. The other thing is the environment that they're in. They're very cold. Mars is very, very cold, and lithium ion batteries, you're going to spend a lot of your energy just keeping them warm enough so that they will be able to function. So, that's, and I've always said, Mars is a continual energy crisis. Is that you will never have enough energy there. There's no, in Earth, we always talk about, oh, we got to radiate, we got to dissipate all this excess energy that we don't have. In Mars, you're going to find some way, if you get a power station, you're going to take that excess heat and you're not going to dump it into the atmosphere. You're going to dump it in your terrarium somewhere like that, in your hydroponics,
Right.
to keep your environment warm, or you're going to
So
dump it
then,
somewhere else.
so then, if you have a nuclear reactor, that's a thorium reactor that could be powering Starship, which would then be the
Yeah,
base for
yeah,
everything,
yeah,
for everything from science to
yeah. Right.
terrariums to maintenance of Optimus. I
Mhm.
mean, possibly even the first human habitats.
Yes. Now, what they might do is I know Starlink satellites are actually using lithium ion batteries in there, which kind of surprised me, because in some ways lithium ion batteries are not the go-to choice for spacecraft, because of temperature fluctuations, stuff like that. But because they're in continuous service and they have like enough energy, they can kind of keep it at the temperature that will work. But if you're going to have like a deep space probe, that doesn't work. And NASA is already using a kind of technology. It's a type of hydrogen-based battery that's really interesting. It can work in like any temperatures, and it's very good. You don't have to worry about cycle and everything else. The thing is, the battery is just kind of expensive to do, and I have to do some reading. I remember looking at this a few years ago and exactly what they use for it. So that might be good. It's just that it doesn't miniaturize quite as well as you'd like. So that might be your kind of mega pack that you
And
would
how
set
do
something up like
production
that.
scaling laws apply to that?
Oh,
In
the
bringing
bigger
down
it
the
is,
cost.
it's great. Well, it's probably okay, but still, it's not going to be as good as like a mega pack. But the thing is, the reason, the early spacecraft that we put up, the Americans put up, were extremely expensive. The components are going there extremely expensive. There were cheaper alternatives. The problem with the cheaper alternatives is that they were too big, too massive, and too sensitive to vibration. So like vacuum tubes were super cheap, and transistors were like really, really expensive. But vacuum tube is not going to survive the shock of a launch. Okay, they're also very heavy and stuff like that. So the early days of space program, cost didn't matter. You said, normally that's a factor in anything,
Yeah.
any calculation that you say, all right, we got to come up with a cheaper alternative. But when the space race was like, doesn't matter, it's just we know you can get the same functionality in all ways for like 1/100th of the cost or 1,000th of the cost, but it doesn't
You're just
matter.
going to be that 2
Things are gonna
steps or
break.
3 steps
We
ahead of
need-
the Soviets.
Yes, exactly.
Cost doesn't
So we
matter.
needed something else, and so megapacks would not be the way. They're cheap on Earth, but they're not going to be cheap. So there's going to be some other way that you're going to need to be able to store that and recharge these things. The other thing is, of course, the battery packs themselves. Are they going to be lithium ion, which is like, those batteries are a little bit lighter than like an LFP, right? Or your standard lithium ion. I mean, these are both lithium, but when you start to put the iron in there, it's a bit heavier. However, they're a little bit better in colder temperatures. They have better cycling and stuff like that. And as far as like, let's say the weight penalty when you're on Mars, because, if you put them in Optimus right now, you're going to make Optimus a lot heavier for the same amount of energy.
Right.
And it's also going to take more space. On Mars, you're like, oh, yeah, the mass doesn't matter that much. You're a little bit worried about the volumetric energy density, that you might have to have a bigger torso. But again, if you scale the whole thing down, maybe you don't need a 2 kilowatt hour battery pack. Maybe you can get by with something that's like 1.5 or 1.9 or something like that. So those things, but you've got to think about the sensitivity, and then the electronics and everything else in there. You have to make sure that they will be able to handle the rigors of the Martian environment. So Optimus as it is, if they send it there right now, kind of the way it's designed, they're probably going to find it doesn't work or it's going to have all sorts of problems. They really have to think about it, as well as just the walking algorithms. Are they going to be able to train it in a simulator to walk in 1/3? The other thing is most of the humanoid bots you see right now are not really designed to go outdoors in normal weather conditions. So you would need some sort of protection, environmental protection, and that's usually known as like IP kind of standards. So intrusion protection, and those standards are to make sure people's fingers can't get stuck in things, that you're able to keep dust out, you're able to keep moisture out, all this other stuff. So, well, we don't have to worry about fingers in Mars. So, the IP protection doesn't have to worry about that right now. The other thing is, I don't think we have to worry about moisture on Mars. If we do, that would be great. So the main thing is that you're going to have to be able to handle dust. And the thing we don't know about in the dust there is like extremely gritty, and it's so it's going to be very abrasive.
So we've heard so much about lunar regolith, right? And how abrasive it is. How does Martian regolith compare to lunar regolith?
It's probably going to be the same because it hasn't had the chance to erode the same way with moisture, kind of getting the fine edges off. It might be a little bit smoother because maybe there was some water in the past, but I'm pretty sure those dust particles are just as abrasive. It's possible of them. Well, they might be a little better because the moon doesn't have an atmosphere either. So it hasn't had the chance to have like the particles. So if you had like a lot of dust storms, the chances are those dust storms may have taken some of the sharp edges out. What I kind of concerned with is also on the moon is that stuff is electrostatically. It's like it gets all over everything and you can't get it off. And you're probably gonna have the same problem that, you've got a lot of magnetism in there. Like Optimus goes out there, next thing you know, it's like shoulders just all covered with dust.
So Optimus with a suit, then? Is that the solution?
Yeah, I mean, there's going to have to be something, some way to counter that effect, and I'm not sure what that's going to be. That dust is going to kind of build up, and you need to make sure it doesn't get in the joints and everything else because it might be strongly attracted. The other thing that is cooling. So if you look at a bot, they have fans in there, just like your computer has a fan, like little muffin fans and stuff like that. And so they're designed to have a lot of airflow there because they actually have to get rid of a lot of the heat. And radiative heating probably won't work that well. And the thing is like, well, can you do it the same way? We can't do it in the moon because there's no atmosphere. There is an atmosphere on Mars. The thing is, it's so thin. The question is whether there's going to be enough. However, the air is amply cold if you need to cool things down. So I'm not quite sure what the energy balance is going to be like when they go through there. They might say, it's just so darn cold, and we'll find some way to recycle any excess heat that the motors are generating right back to the batteries because we had to keep the batteries warm or something like that. So it may be that the way you do the cooling is very different, and that might be good because that dust is going to be nasty stuff going through your ventilation system. You need to have a fan that's pushing the air, and that's just going to be going through. And if you ever looked at your computer, after it's been running a while and the fan starts making these weird noises, and then you look at it and you see like all the dust that's kind of accumulated, making the rotor out of balance. So there's going to be, things that you have to figure out how to do a lot of cleaning steps on that. But that's what the first mission is for, is they're going to go there. It's going to be a spectacular failure in many ways that every engineer did not expect. But they will get such valuable data. Right? That's how it goes. Yeah. I mean, we can simulate all we want. And there'll be like tons of theories that we have out there on what it's like to have a bot walking in 1/3 G. Yeah. And we're going to get it all wrong.
How do you train for that?
Well, you do it. Well, the first thing is
you do it in one of those tanks that NASA uses for the aquanauts.
I mean, they kind of, but I think it's gonna be different. I mean, it's hard to. Have you ever tried walking in water? I mean, you could do something like that, but then you get the resistance of going through. It's just not the same thing. Yeah. The way they train the bot is they're just going to do reinforcement learning in a 1/3 gravity simulation, and then hope that goes over, and there's no like surprises of what's going on. But there's going to be a lot of other physics there that might be a little bit hard to get. Or who knows? They might just nail it right away. They might just say, "Oh, all you do is just turn this dial," or it adapts. And it could be that they take that data, and then you bring a core with you on Starship to actually go through and retrain. So you might be getting a lot of data and say, okay, let's go back here and let's see if we can do something to upgrade it. And that would be an interesting thing, because the bots are going to be making mistakes there, and they're going to have to learn from the environment, and then hopefully you can then retrain the fleet. So again, the more the bots you bring, the better, because that gives you the opportunity to have more testing going on.
Yeah. So
and more training.
NASA already has these rovers. You've got this opportunity, and you've had, how many are there right now? I think, is it 3? You have Spirit, opportunity, then you've got the little helicopter that crashed, but it's
right. Yeah, we had a couple. I think that there might be like a total of at least maybe 6 there, but not all of them are operational, because wasn't there like 2 Pathfinders? And I think maybe they finally expired, and then another one. So yeah, I've kind of lost count, but I think there might be 2 or 3 that are active.
So when you say expired, is it the RTGS unit that's spent its life?
No. They were all solar powered. So I think just about all of them were solar powered, and they just their electronics just faded. They just got too cold. So their batteries failed because they couldn't survive the Martian winter. They'd hunker down and everything and try to come back up. And then the dust covers the solar panels and stuff like that. Right. And again, remember, they were only supposed to last 90 days. Optimus
can just go there and brush off.
And they all lasted like a decade. So it's rather amazing. So I'm sure that they can do the same thing in same ways, but it's a very different environment. And hopefully they've learned something, because a couple of the rovers actually had robotic arms on them. And so from that, we get an idea of how those robotic arms were able to perform, and what kind of, electronics and IP protection and everything else you need to put on those things to make sure they survive. And it's probably a little bit different than what Optimus is. So there's going to be upgrades that need to go on there. And again, I hope they think about the fact that there may be a different size that will flourish much better in the Martian environment than, an Optimus that's 5'8" or 7'6". You might, who knows? Maybe it turns out better to be taller, but I suspect it'd be a lot better to be smaller.
Do you think Optimus will be used to build any sort of infrastructure?
That's possible. That's what I would think, is that part of it could be, I don't know what it is that they want to do. If it's sort of
run those boring machines.
It's possible, or those boring machines could possibly kind of run themselves. I don't see why you need a driver for a lot of these things, but there may be.
Because a boring machine can just fit inside the Starship, right?
I think that's the idea, is it potentially could. Yeah. And so remember, the idea is not to send one Starship, but maybe to send several. So some of them would have, the heavy equipment on there, like potentially a boring machine or something else. Again, if it's like an Apollo style thing where you're just putting some scientific experiments out there, you're probably not going to need a whole lot. But if the idea is like, we really want to prep it and make a base station, and as part of that, a good landing pad, it's like, okay, let's go over here and find a good site and actually start clearing all the rubble, at least make it clear, and then could we pave it in some way with something like that with a local regolith? Maybe they'll do a lot of other experiments. Maybe they're going out there and, if not with a boring machine, doing something else to say, hey, if we drill down, how far do we go down before we actually start finding water and all these other things? So there could be a lot. And then maybe actually building a habitat of some sort where they may already have the components, and it's just a matter of having them either come out there and assemble these things or start doing 3D printing. So it might be you've got a job site out there, and you got a bunch of construction workers, and they're running the 3D printers and, setting those things up, which are going to be really big. And I don't know, you've seen it, is that, basically it's a very large crane, and it just pours concrete, and you just sort of figure out what that shape is going to look like. But there's going to be some setup on those things of setting up, a lot of the frames and everything else to be able to hold everything in place until it sets. And I'm sure there's going to be experiments they are going to want to run, because we don't know what proportions of the regolith are sort of needed along with other things to pour decent concrete. We've got pretty good guesses on the simulant, but when you get there, they're probably going to run a bunch of experiments.
I think the company named Icon has got a NASA contract to use lunar regolith for 3D printing structures.
Yes. Yes.
I think that technology can easily be repurposed for Mars, don't you think?
Yeah, there's another tech that we should also be looking at, and that's I'm trying to remember the name again, but Dr. Martin Bermudez has come up with this idea of blowing glass, and you can use in situ elements for that, and you just like if you put the right kind of ingredients in there, you come up with a glass that's like really strong, stops a lot of radiation coming through, and it's like a very easy structure. I mean, literally, you're blowing a bubble, except you're doing one that's really, really large. And so they're looking into that, and NASA is like taking that into serious consideration. So there may be some other intriguing ways of being able to build these habitats. And in many cases, they probably will require some form of human supervision to run the machines.
Yeah. It's interesting that SpaceX, when they published this video of the Starship mission, that they had these glass domes that they envisaged. So, maybe that's a bit of signposting.
And the thing is that there's a lot of discussion about whether that would be radiation hardened enough, and what kind of glass can do to make sure that you don't have cosmic radiation coming on through there. At the same time, is it to make it more pleasant for people who are there, or is it for plants? So again, it might be that the people don't live necessarily directly underneath it, but there's still like houses in there, other structures that kind of shield them, and every now and then they can go out and go for a walk in the park. Which might be a bit more pleasant than just trying to, actually go outside of the Martian surface. So there's a lot of thought, a lot of ideas going in there. What's going to be ideal? What's going to be best? In some cases, and because the main thing is you want to get light in there. Sunlight is so beneficial for so many things.
Yeah.
And the more natural,
you can grow crops, you can do a lot.
You can grow crops, also heating, it's like if you get this, the whole idea of a greenhouse that will make everything very, very warm. So it could be that has nothing. It's like, we don't care that it's really bad at radiation shielding. We care that it's a greenhouse that's going to make everything warm, and the radiation shielding is then taken care of by structures underneath that thing. So you can live under the dome and everything would be fine.
So you could very well have Optimus, and then some of these machines.
Yes, exactly. This is the idea of is a landing pad. Is that can we create easily a landing pad in the 2-year interim between them getting there and the humans and the next one coming, right? Yeah. And of course, they're going to find out how difficult it is to land Starship on unprepared surface.
Yeah,
and it might be that they lose
gravitational conditions.
Yes. Very, very different. So it could be a little bit tricky, finding out. And they might say, okay, now that the cargo are humans, we're not going to take the risk of just landing out, because we've seen already the difficulty that these landers are having on the moon, keep falling over, and a lot of it is. It could be avionics and other things, but the fact is that the moon is not prepared. You're landing in an area with lots of craters, so they may have landed on the incline of a crater somewhere. Hopefully you are able to adapt for that, but you've only got so much wiggle room. You only get so much time to make that decision.
Yeah.
And Neil Armstrong had to do that. Is that in Apollo 11, they were about to land on some boulders. And that's why he took over and why they moved over the side until he could find a better location. So you don't know till you get there what that surface
if you
is gonna
go
look
back
like.
to Elon's tweet, he says 2031 is more likely, and you have the window opening to Mars every 2 years, or roughly 2 years. So it could very well be that they try and improve on the landings in 2029 and then try and nail it in 2031.
Yeah, again, I do think it's very optimistic here, and that because so you're looking at a window opening up in end of 26, which is what they would like to hit, and that's where you send your first batch of Optimi, and then we don't know how successful that's going to be. And again, it's like if all goes well,
the risk opportunity is really low, right? For 2026 to just send whatever you have, it doesn't hurt.
Yeah, and but you're going to need a lot of refueling. So at that point, for each Starship you're sending, you're going to have maybe a dozen flights that you need to do, and that's where the reusability has to come in, is on the refueling tankers. So you're going to need to do that. And so how many can you reasonably send? And you want to send more than one, because the chances of failure are like really, really high. And the more you send, the greater the chance that you might actually have one of them is able to nail it. Or you get a lot of data from the whole thing that you were able to then find out, oh, okay, these are like all the changes we have to make because we had like 10 different failure modes with their 10 different ships that went in there, and now we've got to correct them. So
do you think they'll try and, even if they send a fleet, do you think they'll try and land all of them together, or is there room to use the software on board to learn from the first initial landing?
That's a good question. I would think you would want to pick a similar landing site and have them be close enough that they could all kind of cooperate. I don't see any advantage of being all around unless you're trying to find the ideal candidate. You might be like, well, there's 3 or 4 we don't know. We literally need to explore that. Let's just go ahead and send them on out there, and then we know which is the best one. And then maybe you have a follow-up flight where you send everything to that site because you found like, hey, guess what? There's plentiful water here. Or there's something about the conditions. It's really, really flat. All these other things. There's some valuable mineral we've discovered. So we won't know till we get there what's going to be best. And again, do you put all your eggs in one basket, or is it better to kind of go around and get a little bit more data? So I'll leave that to the mission planners to be able to figure out where's the best location. But again, we won't know the best location until you actually are able to explore it and explore it up close. And that might be one of the advantages. Again, I said, Optimus is probably not meant to be an explorer in the typical, Lewis and Clark sense that you're like going across the country over a long range. It might be that you intensely explore a very small area to really find out what's going on. And if you have a lot of them going around scouring the whole thing, you can make probably a lot of very interesting discoveries very, very quickly.
You also have the option of sending a Cybertruck. Right?
Yeah. Because again,
and now, if you look at this video, the moment this video was released by Tesla, I said, this is signposting Mars.
Yeah.
The red planet, all of that. And if you look at what Cybertruck is really capable of, look at that. Now, this is something that Cybertruck and Optimus could encounter on Mars very easily. And you have a battery run truck that is tough, hardened. You have Optimus that could really fit into it. You've got the utility factor. You've got the ability to, take on the sort of terrain, as you clearly see, is pretty crazy terrain. The gravity difference should also aid. So there's a lot going for Tesla, for the Tesla Cybertruck to go on one of these trips to Mars and kind of be one of the, instead of having a rover that can only do so much in a day, I think a Cybertruck would be able to do much more, right? Wouldn't that be
Yes. You need to have some kind of rover, and the reason for that is that the rovers are designed to travel a long distance. They do it pretty slowly, but they're designed to explore over a long thing. Humanoid bots are not really meant to cover a long distance. Their locomotion is to take care of things locally. And when you need them somewhere else, you put them in a truck and you drive them there. So you're going to have some way of being able to do it. But you won't put them in the Cybertruck. You'll put them in a variant of it. And the question is, what's going to be the right battery pack, again, for the Martian environment? You don't need the AC. I mean, there's a lot of things in there. First of all, you can take all the NHTSA standards and just throw them out. You don't have to worry about whether you're hitting pedestrians and all this other stuff. So you would probably want to really redesign it for that kind of landscape. You don't need to have it necessarily enclosed. You don't need to have everything slanted that way, because I wouldn't worry about wind drag or anything like that. So you can make it maybe a bit more roomy, a lot easier for the bots to get in and out, because they don't have to. They don't have to breathe, right? You don't have to worry about that. You don't need air conditioning, so you don't need a blinker, But so there's going to definitely be reasons to want to vary the whole thing. So it might be more of like an open, almost like golf cart. You just jump in and then they zip you off to somewhere else, and then you pop out.
Okay, let me just try and bring up this post. This is from Casey Hanmer. So Casey responds to Elon saying, "Can we send a few tungsten rods I want to see what's under the surface?" There's this entire conspiracy theory around a tungsten weapon called rods from God. Right.
Okay. Yep.
Yeah. And so if you have a few tungsten rods that you can chuck down from a Starship in orbit, I think that's what he's alluding to. What do you think?
Yeah. So I think what he's doing is let's create an artificial asteroid to go in and crash into an area surface and like blast a hole there that we can then dig down and see what's in there. That's probably yeah.
Also, remember, it was, I think it was at the end of 2023, this asteroid crashing into Mars.
Yes, exactly.
Right. And then that was when they realized that there was a lot more water ice under the surface than they previously thought. And the equatorial region as well, not just at the poles.
Mm-hmm.
So it's an idea that is interesting, right? I mean, because you have precedents for this. And then if you can have rods from Elon, tungsten rods from Elon being sent down to Mars, kind of like an asteroid. It could.
You may not need it, because there's a good chance one or two of those starships will do it for you. They'll auger in and they just go over and just look at the hole that it made, and then check it out. So that's the other possibility. But it brings a good point, because one of the experiments, one of the last rovers, was to drill into the ground, and remember the difficulty they had doing that. And the reason it was so hard to do it is not just that the regolith and everything was hard. I think it was about as hard as they expected. The thing is, the gravity is 1/3, and as we all know, it's like in order for your drill bit and everything to work, you got to push down on it. And that means you like lean into it, put your weight into it. Like, well, my weight's like 1/3 as it is on Earth, so it's a lot harder to get in there. And so this is the big challenge for drilling there, is trying to figure a way to be able to create the downward force that will allow your bit. And so maybe it's just like, we're just so frustrated, the rod's from God, just boom, just go down there, blast a hole in there, and let's just go in and check out what's underneath.
Yeah. Do you think it'll be easier for those boring drilling machines on Mars than on Earth? And how much so?
I don't know. It's again, I imagine
the reason I ask you this is because underground habitats
are going to be important.
Very, very important, because they shield you from radiation. They're easily the first go-to solution for a human habitat before you can build on the surface with everything else, right?
Yeah, and the thing is, we don't know how hard that bedrock. I mean, bedrock is like the worst stuff to go through. And if Mars is like nothing but bedrock, it could be a lot harder than here. The other, without the gravity, because I was even thinking, was like, when that Cybertruck was going up that Hell's Canyon, I'm trying to think, it's like, okay, is the lighter gravity there going to make it easier or harder? It's like your traction's not going to be as good, but then again, you don't need as much traction because your vehicle doesn't weigh as much. So it may be that it's kind of equal there, but it could be that the lower gravity is going to be a hindrance in many ways. That's going to be very, very unexpected for a lot of experiments in a lot of engineering equipment.
You could just have Cybertruck bouncing off the surface there in the ways that you didn't.
Yeah, and then the question is, are the wheels going to slip? We just don't know if they're not going to get as much traction there, just because It's
What
not
sort of
as
wheels
heavy.
do you think? What sort of tires and wheels do you think you'd need on Mars?
Well, on the lunar rover is made out of like this weird tungsten wound fiber that was airless. So the question is, are they going to try to go with something that's airless, or just use run of the mill tires and just send enough replacements? It could be that you can send so much stuff on there that it's easier to go ahead and use cheaper things than something that's super expensive, as far
Right.
as the durability. So when you throw a lot of numbers, so again, like with Starlink, those satellites are using normal lithium ion batteries, which no one would use for like any sort of kind of satellite thing. But
Yeah.
we already know that they have like a 3 to 5 year lifetime. They know how to get them to work fine. And they got so many of them up there. So what if one of them fails? I mean, and so it's the difference between your satellite costing $250,000 versus it costing like $250 million. And
Yeah.
the whole idea of Starlink is like make them so cheap that you just flood the zone with them and you don't worry about failure. So if you're sending a lot of these things up there and you get enough spare parts and you have these bots that can change a tire, and again, they might change the design of the tire to be more like a Formula One kind of tire. You have one lug nut, right?
Right.
And there's a lot of reasons you don't want to do that in a normal, everyday consumer vehicle. But for what's up there, it's like, yeah, maybe just make it so it's a very easy maintenance item to pop it on there. And if the tire wears out, so what? The one advantage you have, unlike the moon, is that you can pump air into it, and it doesn't matter whether it's carbon dioxide or nitrogen or whatever, just so long as you put something in there. The moon, the problem is like, if you want to fill up your tire that's gone flat, you got to bring the air supply with you. So Mars invites a lot of things that, if there's things we have to pressurize, let's just use the local stuff. And I don't think carbon dioxide is going to like be really bad for the rubber or whatever you have. I mean, there's obviously some you don't put in there. It's like ozone you don't want to put in your tires, because I think
Well,
it eats away.
you anyway, you put nitrogen in your tires to keep them cool, right?
Oh, it's a myth. It has to do with the atomic weight of the nitrogen that you put in there. That supposedly it makes them work a little bit better than just having the oxygen mixed in there. The thing is, air is 75% nitrogen. So is it really worth getting that little bit of oxygen out there? And some people might say, oh, the oxygen attack is like, it's baloney. So it's, I think that's been a myth that's been dispelled, because everyone thinks, and you get a little bit better. It's like,
The things you can do.
I don't
with
think it's
marketing.
a big deal. Yeah, exactly. So,
Okay, so I want to pick your brain on the communications network. Could Starlink, and we've talked about this on Over the Horizon before, how does Starlink play into this? Could you have one of those starships carry a lot of, so with IFT-7 and IFT-8, we already see SpaceX trying to deploy these dummy Starlinks, the next-gen Starlinks.
Yeah.
Do you think the current Starlinks will suffice, or are we looking at next-gen Starlinks? And could you have just one? How many would you need? And would one Starship carry enough that you need, to build a communication network around that?
Right. So the big question is, the higher the orbit you are, the fewer that you need, right? Because you get a lot of coverage.
Yeah. The shadow is bigger. Yeah.
Right. But the thing is your latency goes down. So if you're trying to do communication across Mars, then you would want to have them in low Martian orbit, like you do here. But if we're really just talking about, so who are we communicating on the other side of Mars? What's the difference with latency? Are the Optimi playing playing Diablo, that they need to have that? It's like, no, the main idea is to be able to easily communicate to Earth. So you want to have enough of a swarm around there that there's something you can communicate to, and then it takes it and relays that message back to Earth, probably through a couple other relay satellites somewhere along the way.
Yeah, and where would those relay satellites be? Would they be like at Lagrange points or the asteroid belt?
Yeah. My feeling is that they're much easier to keep them stable at Lagrange points, and then you spread them. I think that what you would want to do is you'd want to have them in Martian Lagrange points, Martian orbit Lagrange points, and Earth orbit Lagrange points, and have enough of them around there. And then, kind of as these orbits go around there, you'll always get a couple of these that kind of link up to be close enough that you would be able to do something like a laser signal. And then the question is, like, around Mars orbit itself, around Mars itself, how many you would need. So you know whether they would be able to pick up the signal and directly relay it to Earth, or whether you have like a bunch of these Starlinks that are getting whatever information, they then send it over to like this really big one that's positioned in such a way that it's never blocked. Because the problem with orbiting around Mars is like every now and then it's like, whoops, you know, Mars is in the way for transmitting to Earth. That's why we have to bounce the signal off. So you get that. You probably get some big one that maybe you're able to communicate. Well, see, the thing is, the one that's blocked can always transmit to another, transmits to another, and then you'd probably get it to a Lagrange point that's in between Mars and the sun. So whoom, you hit that one there, and that one is probably like just really big and just a lot of power, and now just like beams wherever it has to, either straight to Earth or bounces off another satellite, because you want to use a laser link. The normal radio will be too slow. And the main thing you want to do is, it's not that you want to make the communication fast, you know, like without any latency, because the fact is there's latency. There's nothing. I mean, they're so far apart.
But also, you'd also want to have some Starlinks on the Starship on the way to Mars for diagnostics.
Yeah. For communication, the main thing is the bandwidth. That's what's important. Is that we're going to have so much data. We just want to be able to download, you know, terabytes of data quickly, and then get it back. And then, and again, so it could be that we're getting a lot of data that we need to use for training data or something like that. We just want to send all this stuff back. So the main thing is not that things go through the pipeline really quick, is that the pipeline is really big. And so the data just comes in a torrent, and you've got tons of this high quality video. Even if it's 20 minutes delayed, it doesn't matter. So again, that's why I say, you know, a couple milliseconds added latency on the Martian side doesn't matter in the grand scheme of things compared to what's going on there. So you probably don't
at least initially, right?
Yeah. I mean, so they could basically do like, maybe it's like 3 or 4 geosynced or Martian synced satellites that would be enough to be able to do the coverage. You don't have atmosphere to worry about, and again, you can position these things such that they're favorable for whatever landing zone, which is probably equatorial. I mean, we're not going to, so it's like, well, we're just worried about that band. Don't worry about anything up at the poles for now. We're not going to be there. And we only have one landing site. So we really focus on that. So I don't think you need to have like them spinning around. Probably if you do, they're just basically in a stationary orbit, kind of spread around, or you may have a few, but you make sure that the inclination of the orbit is you know, almost equatorial, and you don't have to go to high latitudes.
Yeah, but it's interesting. You could very well have Optimus if you potentially, by 2027, if Optimus lands end of 2027, right? If they take off at the end of 2026, you could. I'm talking about the Mars sample return. You might not need to bring them back. You could have in some amount of in situ analysis of those samples on Mars itself.
Yeah. Oh, sure.
Science on Mars.
They're definitely going to be bringing all sorts of equipment to allow them to do assays of the local material. So again, if you want to be building a concrete pad out of the local regolith, you want to go and you want to find out what's going on there. That's exactly what civil engineers do. Whenever they go to a site and they start setting something up, they've got to test the local soil conditions and the soil that's going to become part of the aggregate to make sure you get it right. And you end up getting some strange chemical effects that can cause your land. I know this locally because they did a lot of construction work near my house, and the bridge that they built was like nice and beautiful and stuff like that, and all the concrete. And within 10 years, it just started exfoliating in a weird way. We just thought it had to do with Michigan weathers. And it turned out it's like this weird, it's some sort of silicate reaction that they have, that there were some components of the local soil that they weren't aware of, that when you put it in there actually causes really slow degradation of the concrete. You can mitigate it by putting in these other things in, but they hadn't quite known about it at the time. So again, you go and you test your soil to find out what's in there. So they're going to have that.
You can't modify for what you don't know.
Right. And the same thing is like, if they already have that stuff, do they really have to run around and pick up these interesting samples that people have? They might already have more than enough interesting samples right in front of them. They don't have to go anywhere. So just pick up this rock, take a look. So there may be some advantage. And then, I'm sure there's some stuff on Earth that's really hard to bring, that is just very heavy, that, just requires a certain infrastructure that would be nice to have them back. But I'm sure they'll be able to do a lot with what they have right there.
Yeah. I mean, you could do. We've already done so much with the Mars orbiters that NASA has up there. Just imagine potential of what you could do with Optimus on the ground, in addition to rovers.
Yes.
How much of joint exploration or joint science do you see the rovers between the rovers and maybe some like the Ingenuity helicopter, Mars, and Optimus, all three of them put together?
I think they'll be complementary because, again, the Optimus science that's going to be going on there is going to be of more practical value for what has to happen. So I really think it's like Optimus is a civil engineer, not Optimus a scientist. So you're going there trying to figure out what you have available, do whatever kind of local science there that helps you in your end game, and that is like, to build these structures the way you need to have them done. So it doesn't mean there won't be any useful science there. There'll be some very interesting science, but they're not going to be there to answer the questions like, was there life formerly on Mars? How was Mars formed?
You don't need those answers.
They may stumble across some of that stuff that will be kind of complementary. And at the same time, they will probably discover
you could send an Optimus in a Cybertruck to the site
where
that squarish object structure was found.
You could definitely do stuff like that. The other thing is that the discoveries that they're making there may help inform the other ones that you're trying to do. It's like, oh, by the way, we've kind of discovered this. Oh, that's kind of interesting. That will make it easier for us in this particular mission, or to look for something else. So they will be kind of complementary. Again, think of them that way: is that Optimus more as an engineer than a scientist.
Okay, so let's crunch some numbers. So what do you need? You need whole bunch of optimi. You need a drill, one of those big machines,
be nice.
or two. You need a bunch of Starlink satellites, and you need kind of a separate one with a couple of nuclear reactors, some sort of energy storage units, and of course, and then you build on that. How many do you think will be in the first fleet of Starships? How many Starships do you see going in the first batch? And I'm not counting those that are used for refueling in space.
Yeah, I don't see more than half a dozen. It's clearly more than one, and it's like the minimum is probably three. They may be some optimistic projections saying, oh, we'd like to have 10 or 12, but the reality is it's probably going to end up being somewhere around 6, because the time frame is just too close. I mean, they could. I just don't think that they'll have the infrastructure ready for that. You got to build them, you got to test them out, and then is the program mature enough at that point to go ahead and do it? You want to have a certain amount of redundancy in case one or two of them fail. That you got to look. So you don't put all the optimi in one ship. And you don't put all the boring machines in one ship, and so you kind of set it up that like it'd be nice to have both of these things, but if one of them ends up auguring in, at least we get the other one. We'll have enough of everything else. So you probably do it, but at the same time, some of the ships may be set up as like, well, once you put the boring machine in there, it's like we only have enough payload for like 2 optimi. That's it. Nothing else. So
I mean, even if you're left with 2 optimi, supposing that if God forbid, like you have a Starship with, let's say, 100 optimi, and it crashes and you just have 2 that survive. That's still 2 optimi. On Mars.
Yeah, exactly. So it's there's so many unknowns, and SpaceX likes to move fast and break things. And if you ask anyone on there, it's like, oh, you think they'll all stick the landing the first time? Like, of course not. We're not even have a chance. Are you kidding? We'll be lucky if, we'll be happy if one of them survives, probably, because that is a very ambitious timeline to be able to do it. And then again, the pleasant surprise is like, you're proven wrong that they do all of it. And of course, it could be that, I don't know if they're all going to try to simultaneously land at the same time.
So how do you simulate landing on Mars? If you can simulate kind of moving around and walking for Optimus on Mars,
they've done simulations, and part of what the whole even Falcon 9 project was about was understanding what hypersonic flight is, and being able to do supersonic landing birds and stuff like that, because the Earth's upper atmosphere is very similar to the density that you'd see on Mars. So they're gaining a lot of data. They have a lot of ideas of exactly how they would do it. And the question is that when they go there, I are they doing like a direct capture kind of thing? And in other words, they're heading right towards Mars, and they're just gonna hit it and go through the atmosphere and not actually get captured into orbit. Or is there, and they might want to do something to definitely make sure to delay all the ships. I don't think you want them all to try to land simultaneously. I mean, you see the images that are like, oh, coming down at the same time. It's like, no, I think you want to space them out at least a couple of days, because when that first one goes in, you're going to get a lot of valuable data, and you need enough data to find out, what worked or what didn't work or where the problems, so that maybe the second one can then learn from that potential failure, stuff like that. So it could be a huge mistake trying to get them all to stick the landing at the same time. As much as it'd be nice, I mean, it was something else watching, Falcon Heavy with the two boosters coming down together. I mean, that's just so cool.
Imagine half a dozen Starships coming down together.
Yes.
But at that point, but not.
Yeah, they already had the experience of landing those things. So, yeah, you wouldn't want to try that on the first try. And I think the energy modes, it's almost better to basically hit the atmosphere and use it for aero capturing anyway. And I'm not sure that they're going to go into orbit, but I could be wrong. It might be that they have a way that they'll do like the aero capture, but not actually a full reentry, and use it to slow it down and then get themselves into a proper orbit. Pick their site right, so you can go ahead and hit the site exactly, assuming they all want to land around the same area. And that's the other thing is just the sighting information you'll get from that landing will make it easier for the second and third ones, because you'll already have higher def images coming in there. You'll have an idea of what the hazards are.
Yeah. I mean, if you look at this video from SpaceX, it does look as if they're using the atmosphere to some extent to brake.
Absolutely. You want to, otherwise you are wasting a lot of fuel to slow you down for the capture. And so that's always been the idea. It's just that sometimes there's like a direct capture that you use it, you keep on going through the atmosphere, and then you finally land where you want. And the other is that potentially use that to go into orbit.
Yeah. It's fascinating. When and you have there are, I think 1, 2, 3, 4 of them landing together, 4 landing pads.
Yeah.
So
in the future, yes, exactly. So well in the future, once you've had those landing pads prepared, you could have a scenario like that where they all come down at the same time. But at first, I think you want to have them spaced out.
Wow. Well, this has been a fascinating chat, Scott. I mean, thank you so much. We've everything you wanted to know about Elon's plans and what they could mean. You have to watch this video. That's all you need to do. Thank you, Scott. You're brilliant as ever. You never disappoint. Thank you so much.
Okay, you're welcome, Royden. It was a fun chat.